Ever wonder why the tiniest particles in the universe don't follow the same rules as the objects we see and touch every day? Welcome to the bizarre yet fascinating world of quantum physics, where the rules of the game are entirely different, and the players are notoriously elusive. Quantum physics, at its core, is a branch of science that grapples with the fundamental building blocks of the universe. It deals with discrete, indivisible units of energy known as quanta. This is a realm where particles can exist in multiple places at once, where they can pop in and out of existence, and where they can even be entangled. A strange phenomenon where the state of one particle can instantaneously affect another, no matter how far apart they are. The quantum theory, which forms the backbone of this field, is a bit like the rulebook for this enigmatic game. It describes how these quanta interact with each other and with the world around them. But unlike the rulebooks we're used to, this one doesn't tell us exactly what is, but instead it tells us what can be. It's a probabilistic theory, meaning it deals with probabilities rather than certainties. It tells us, for instance, not where a particle is, but where it might be. And it's this inherent uncertainty, this fundamental fuzziness, that sets quantum physics apart from the classical physics we're familiar with. Quantum physics is, in many ways, a journey into the unknown. It challenges our understanding of the universe and forces us to question our assumptions about reality. But although it's complex, it's not inaccessible. In fact, it's a field that's ripe for exploration, full of mysteries waiting to be unraveled and secrets waiting to be discovered. So yes, quantum physics might seem confusing, even intimidating, but stick around and you'll see it's a lot simpler than you think. It's a realm of endless possibilities where the rules are strange, the players are elusive, but the game is undeniably fascinating. Imagine tossing a ball. We can predict where it will land, right? But in the quantum world, things aren't that simple. In our everyday world, objects have definite properties. A ball is either in your hand or it's not. But in the quantum world, things can be much less certain. This is where we enter the realm of superposition. In quantum mechanics, superposition tells us that a particle can be in multiple states at once. It's as if the ball is both in your hand and not in your hand at the same time. Doesn't make sense? Let's delve into the famous thought experiment of Schrödinger's cat. Imagine a cat inside a closed box, along with a radioactive atom that can decay to kill the cat. Until we open the box, the cat is both alive and dead, in a superposition of states. Only when we check, the superposition collapses to one of the possible outcomes. The cat is either alive or dead. Now let's move from superposition to another mind-boggling concept: entanglement. Two particles can be entangled in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. Picture it like two entwined dancers moving in perfect synchrony, even if they're on opposite ends of the universe. This idea puzzled even Einstein, who famously referred to it as spooky action at a distance. Quantum mechanics defies our intuition and the rules of classical physics. It's like a game where the dice are not just thrown, but they can also be in a state of being both thrown and not thrown at the same time. So, welcome to the quantum world, where particles can be in two places at once, where they can spin in two directions at the same time, and where they can be entangled over vast distances. Here, the reality is much stranger than fiction. In the quantum world, it seems like anything is possible. Have you ever tried to measure something but the mere act of measuring it changes the result? Welcome to the uncertainty principle. Now, let's delve into one of the most mind-boggling concepts in quantum physics: Heisenberg's uncertainty principle. This principle, as conceived by Werner Heisenberg, essentially states that you can't know both the position and velocity of a particle with absolute precision. The more precisely one measures one quantity, the less precisely the other can be known. It's not about the limitations of our tools or our methods, it's a fundamental aspect of nature itself. Imagine you're observing a tiny particle under a microscope, trying to pinpoint its location and speed. As you zoom in to get a better view, you shine more light on the particle. But here's the twist. The photons of light, in their interaction with the particle, will inevitably change its speed and direction. The very act of trying to observe the particle has altered its state. The more accurately you try to measure its position, the less accurately you can know its speed, and vice versa. This isn't an issue of needing a better microscope or a more advanced technique. It's a fundamental aspect of the quantum world. The uncertainty principle is not about our inability to measure, but rather about the nature of the particle itself. The particle doesn't have a definite position and velocity until it's measured. It's not that the particle is being sneaky or elusive, it's just the way things are in the quantum realm. This might seem strange, especially when compared to the macroscopic world we're used to, where we can measure both the speed and position of, say, a car with great precision. But in the quantum world, particles don't play by the same rules. In essence, Heisenberg's uncertainty principle tells us that the universe isn't as predictable as we might like to think. It introduces a kind of fuzziness into the fabric of reality. And while this might be unsettling, it's also a fundamental part of the intriguing and often counterintuitive world of quantum physics. The uncertainty principle shows us that in quantum physics nothing is certain. You might think that quantum physics is just for scientists in labs, but did you know it's a part of your everyday life? Let's take a peek into how quantum physics has a starring role in our day-to-day lives. It's like the invisible superhero, working behind the scenes to make our lives easier and more technologically advanced. First off, think about lasers. Yes, those bright beams of light that you see at concerts or in a barcode scanner at your local grocery store. They're a product of quantum physics. Lasers work on the principle of stimulated emission, a quantum mechanical effect where a particle interacts with an electromagnetic wave and shifts to a lower energy state, emitting a photon in the process. This photon then stimulates the emission of more photons of the same frequency, creating a concentrated beam of light. Quite remarkable, isn't it? Next, let's talk about semiconductors. These are the heart and soul of most electronic devices we use today. From your coffee maker to the computer you're using to watch this video, they all employ semiconductors. These materials owe their unique properties to the quantum mechanical nature of electrons. The fundamental understanding of the quantum behavior of electrons in these materials is what allows us to manipulate their properties for our use. And speaking of computers and smartphones, did you know that the very existence of these devices is an ode to the principles of quantum physics? That's right. The transistors that form the basis of modern computers and smartphones operate on the principles of quantum mechanics. The ability to control the flow of electrons in these devices, which is crucial for their operation, is a direct result of our understanding of quantum mechanics. So, the next time you use a laser pointer, snap a selfie on your phone, or even brew a cup of coffee, remember that you're witnessing quantum physics in action. So you see, quantum physics isn't just about tiny particles, it's about the world around us. So what does all of this quantum talk mean for us? It's an entirely valid question, and one we've been circling around for the duration of our journey. Quantum physics, with its principles and paradoxes, might seem like an abstract field, far removed from our everyday lives. But that's not quite the case, is it? We started off by plunging into the quandary of quantum physics, diving headfirst into the deep end of this fascinatingly complex field. We saw how quantum mechanics, with its wave-particle duality and superposition, challenges our understanding of the world at its most fundamental level. These principles, while perplexing, are the underlying mechanisms of the universe, the code that writes reality itself. We then grappled with the uncertainty principle, Heisenberg's famous proposition that we can't know both the position and momentum of a particle with absolute precision. It's a concept that might seem counterintuitive, but it's a cornerstone of quantum mechanics, and as we've seen, it has profound implications for our understanding of reality. Finally, we explored the tangible implications of quantum physics in our daily lives. From the transistors in your smartphone to the lasers in your DVD player, quantum physics is at work everywhere around us. It's the secret behind modern technology, the silent force powering our digital world. So what does all this quantum talk mean for us? Simply put, it means that the world is far more intriguing and interconnected than it might seem. It means that our reality is built on a foundation of principles that are as fascinating as they are elusive. And it means that every day, when we interact with technology, we're experiencing the practical applications of these principles, whether we realize it or not. So, the next time you use your smartphone or watch a laser show, remember, you've got quantum physics to thank for that.